So here's the handout that I'm going to share with you guys. So at the top I write some things that I told you last class about what's a polynomial. Then down here I define what we mean by factor. You know, what we mean by completely factored. Completely factored means all the factors are either of the form x minus c, or they're like prime factors, or they could possibly be repeated, of course. And then the order of the factor is the largest, you know, power of the factor, which appears in the factorization. And then we had the factor theorem, which said that x minus c is a factor f of x if and only if f of c was equal to 0, which is to say that c comma 0 is an x-intercept, right? In the previous video, I actually worked out examples 1, 2, and 3 on the board. So here's what they look like. So like, you know, on the board, I factored the minus outside like parentheses, you know, 2x cubed plus 6x squared there, if you look at what I wrote in the last video. But anyway, here's the long division for that one. Now, I've already talked about example 1, 2, and 3, so I'm going to skip ahead here to example 4. All right. Actually, we talked about example 4 as well. So here's example 5. All right, let me talk through this one for us. All right, so example 5, I have x to the power 6 minus 6x to the 5th plus 40x cubed minus x squared minus 54x plus 120. And somebody tells me that if you plug in 1, or if you plug in 2, or if you plug in 3, you get 0. And also if you plug in 4, you get 0. So that means that this 6th order polynomial has a x minus 1, x minus 2, x minus 3, and an x minus 4 factor. Now if you multiply these guys out, that gives you x to the 4th minus 10x cubed plus 35x squared minus 50x plus 24. So we know that we can divide this into f of x and get something nice. So that's what I do here. X to the 4th minus 10x cubed plus 35x squared minus 50x plus 24. Taking this, I'm dividing it into the polynomial. So I start out with the, you know, to get x to the 6th, I multiply x to the 4th by x squared. I put x squared goes over here in the way this typesetting works. But so x squared times x to the 4th times that stuff gives you these terms. And then you're left with a 4x to the 5th. So next up, to get 4x to the 5th, I need 4x times x to the 4th. So that's why I put these terms down here. So 4x times these things gives me those things. So like 4x times x to the 4th, it gives me 4x to the 5th. 4x times 10 minus 10x cubed gives me 40 minus 40x to the 4th. And then they're distributing the minus through here. 4 times 35 is 140, and that's why I've got this 140x cubed there. 4 times 50 gives me 200, right? 4 times 24 is 96, so you got that, right? And then you subtract these, you're left with a 5x to the 4th. So next up, oh, hi, Benjamin. Next up, we've got we need a 5, because 5 times x to the 4th gives me 5x to the 4th. And then like 5 times 10 is 50. 5 times 35 is 175. 5 times 50 is the 250. 5 times 24 is 120. Since we did this right, the remainder is 0, right? Okay, great. What does all this mean? Okay, that's really the question then. And what this all means is, let me turn the light on here. So what does this give us? This gives me, if I can zoom out a bit here, what's he up to? Up to something. Let's see here. So what I get, maybe I can do it like this. What I get from this is, get straight to the point here. We get f of x equals the thing we divided in, which is all this, right? But I'm going to rewrite that as what it is. That's x minus 1, x minus 2, x minus 3, x minus 4, right? And then that times what's up here, x squared plus 4x plus 5. And so there you go. That is f of x completely factored in this case. All right, and I know it's completely factored because this last one is prime. You know, you can complete the square on this and see that it's x plus 2 squared plus 1. That's prime. We've dealt with that one before. And so there it is. Benjamin, careful up there, buddy. Next example. Example 6. Passed you the eraser. Here we go. Example 6, we have x to the power 5 minus 16x cubed minus 16x cubed plus 12 minus 12x squared plus 99x. I tell you that x minus 3 squared is a factor of f of x, right? So let's factor it. So what I do is x minus 3 squared is what? That is x squared minus 6x plus 9, right? And so hey, give that back to me. Here, you have this one. There you go. And so like I was just saying, x minus 3 squared is x squared minus 6x plus 9, yeah? So I'm dividing x squared minus 6x plus 9 into this fifth order. And to do that, I start with x cubed, right? X cubed times x squared gives me x to the fifth. X cubed times 6x gives me 6x to the fourth. X cubed times 9 gives me this 9x cubed. Of course, you got to pay attention to the signs. We subtract them. We bring down this 6x to the fourth. And we get 6x to the fourth minus 16 minus 9 is minus 25x cubed. Bring down this minus 12x squared. Okay, to get the 6x to the fourth, I need to do plus 6x squared. 6x squared times x squared is 6x to the fourth. 6 times 6 is 36. 6 times 9, 54. You take the difference, you get 11x cubed. To get that 11, we need this 11x. 11x times x squared gives me 11x cubed. 11x times 6 is 66. 11 times 9 is 99. And then finally, you take the difference, you get remainder 0. That's good. That means that, in fact, we have factored it. And what do we factor? What we have found for this one is that f of x is equal to x minus 3 squared, which was what we divided into it, right? Times what? Times x cubed plus 6x squared plus 11x. All right? Then the question is, can we factor that, right? So, well, we can factor an x out, right? So you've got x minus 3 squared times x squared plus 6x plus 11. All right? And it turns out that that's it. That's all you can do, because the quadratic there, all right, the quadratic is, uh-oh, he's up to no good. The quadratic there is prime. Let me zoom in a bit. So, Benjamin, don't do that. Monster. Interference. All right, so complete the square on that. We've got x plus 3 squared minus 9 plus 11, Benjamin, which is equal to x plus 3 squared plus 2, right? So this right here, Benjamin, dude, stop that. Benjamin, you're not helping me, buddy. You want to go home, right? So this is prime. Because when we complete the square, we get, plus a number there. Or of course you could look at b squared minus 4ac for this. Anyway, my point to you is, hey, we're done. We've completely factored f of x again. All right. So the tricky thing, of course, was figuring out that if you want to factor out x minus 3 squared, if you want to factor out x squared minus 6x plus 9, sorry, I got to zoom back out. If you want to factor that out, well, long division is the way to go there, right? So I don't want to get you with my laser. Okay, so that's example 6. We've completely factored this polynomial. What are you making? Example 7 is a little bit easier. Here we have f of x is x to the 4th minus 81, right? We don't really need long division to factor this thing. In fact, this could have been a problem on test 1, right? But anyway, I'm just illustrating long division again. You're given that x squared minus 9 is a factor of f of x. Let's see what that does for us. So we can divide x squared minus 9 into x to the 4th minus 81. I start with x squared. That gives me x to the 4th and minus 9x squared. Take the difference. You're left with 9x squared minus 81. So that means I add a 9 there. That brings down 9x squared and 81. You get the difference is 0. So what does this all mean? This all means that we get x to the 4th minus 81 is equal to x squared minus 9 times x squared plus 9, right? Of course, that's not surprising. I hope a lot of you already knew that, right? And so if that's f of x, are we completely factored? Are we completely factored here on that one? Not yet, right? So if my f of x is this guy, then I can still break that down further, right? That's x plus 3 times x minus 3 times x squared plus 9. So there you go, Benjamin, monster. Completely factored. There's your example 7. What are you doing? They can't even. I don't think they can even see you. What are you trying to do? I don't think they can even see you. You goof. I don't know if you guys can see it or not. Benjamin's trying to jump in front of the camera. All right, let me focus here. I got a little bit more theory to share with you guys. And I'll reiterate these things again when we're together in person, but just want to take a second here to talk about the complex factor theorem. This is, of course, not as important as the factor theorem, but it is something that I'd like to share with you guys, so I'll do that. So the factor theorem is also true for complex roots. However, in the complex case, something really nice happens. The complex roots come in conjugate pairs. If you've got f of alpha plus I beta being 0, then you get f of alpha minus I beta being 0. This alpha and beta, they're just Greek letters. Don't be scared of them. They're just numbers. And so when you multiply the alpha plus I beta factor with the alpha minus I beta factor, what happens is something really cool. You get x minus alpha squared. You get plus this x minus alpha I beta minus this x minus alpha I beta. So these guys cancel, and you're just left with x minus alpha squared plus beta squared. In other words, there is a one-to-one link between complex factors, which come in conjugate pairs, and prime polynomials of this form, all right? So the complex factor theorem is simply this: x minus alpha squared plus beta squared is a factor of f of x if and only if f of alpha plus I beta is 0, which is also paired with f of alpha minus I beta being 0. Moreover, this x minus alpha squared plus beta squared, this prime polynomial is a factor of f of x if and only if both this and that are factors of f of x. Now, so if we were going to factor over the complex numbers, we would, want to break up this into the product of that and that. Here's an example. You have x to the 4th plus x cubed minus 11x squared plus 9x plus 20. You're given that f of 2 plus I is 0, factor f of x. Okay, so by the complex factor theorem, we know that x minus 2 squared plus 1. So here my alpha is equal to alpha is equal to 2. My beta is equal to 1. All right, so I got x minus alpha squared plus beta squared here, which when you square it out is x squared minus 4x plus 5. And then I'll do what we've been doing all today, which is divide this into that with long division. And when I do that, I get, well, I start with a x to the squared here. So that gives me x to the fourth minus 4x cubed plus 5x squared. Subtract that, I get this. Then I need a 5x to get 5x cubed from the over here, multiplying that. And then I subtract those, I get 4x squared minus 16x plus 20. To get this 4x squared, I put the 4 here. 4 times x squared is 4x squared. 4 times 4 is 16. 4 times 5 is 20. Thankfully, we get 0 again. What does this all mean? Well, let me turn the lights back on. I can write down what it means for you. So on the sheet I'm collecting from you guys, I just want you to basically put the answer for every example on the sheet. That's the idea. It's not terribly sophisticated. Oh my goodness, what a mess. Benjamin. All right, Benjamin. Mm-hmm.
Amazing.
Mm-hmm. All right, let me zoom out a bit here. Hopefully you'll be able to see it. I have to write up a little bit higher. So f of x, right, is going to be equal to, from this calculation here, that x to the fourth plus x cubed plus da 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 plus 20, f of x is going to be equal to x squared minus 4x plus 5, which we know is prime. All right, that's prime. It came from, you know, the complex 2 plus I 0. So that's a prime polynomial. And we factored out x squared plus 5x plus 4, which looks awful similar, doesn't it? But it couldn't be more different. Because x squared plus 5x plus 4, we don't need completing the square to understand that. That we can straight up factor. So we've got x squared minus 4x plus 5, which again is prime. And then we've got x plus 1 times x plus 4. And so there you go. We have factored f of x completely right there. All right? So that's the answer to example 8. Okay? Example 8 has it. There's the complete factoring of example 8. Come on. Why my power cord not working? Oh, Benjamin has made my power cord come out. A little monster. Okay, so there's example 8. Let's go on here. All right, you. Think you're getting away with something, huh? Uh-huh. Example 9. Here we have x to the fourth plus 2x cubed plus 2x squared minus 174x plus 369. I give you that f of minus 4 plus 5i is 0. All right. Thankfully, you don't actually have to show that. That would be a pain to plug this number into that expression and show that it works out to 0. We'd be here a little bit. That'd actually be a pretty tough calculation to show this. Thankfully, you're given it. And since you're given it, you know by the complex factor theorem that here alpha is minus 4 and beta is 5. So we get x minus alpha, which is x plus 4. Beta squared, here's 5 squared is 25. So we've got x plus 4 squared plus 25, which is x squared plus 8x plus 41. All right, that's a factor. So we can divide it out using long division. And when we do that, we get x squared minus 6x plus 9. So what's the answer here? So listen, you know, you ultimately you have to learn the long division for yourself, right? So I'm hoping that I've given you 10 examples of 10 pretty non-trivial examples of long division in this handout, and you can try each one of them for yourself, you know, and you can see whether or not you understand the method. And you've got all the steps to look at, and this is computer generated, so there's no mistakes in here, I'm pretty sure. So we've got x x plus 4 squared plus 25. That's my initial factor. And then what was left? What was left was x squared minus 6x plus 9, right? And now the question is, are we done? Is this completely factored? The answer is no, right? We can factor that further. How can we do that? Let me zoom in a bit here. And if you can't see what's on the whiteboard, I mean on the projector screen, good, and however you're watching this video, keep in mind I am posting the handout in Canvas, so you can just like look at it on your computer screen, you know. So of course this x plus, hi Benjamin, about to call you Matthew, what's wrong with me? X plus 4 squared. This because you're being crazy. X minus 3 squared is how this factors. So there you go, that's the answer to example 9. We can factor the given polynomial like that. That's completely factored. All right. So let's look at example 10. Because Benjamin is going to get crazier, I'm afraid. My markers, what are you doing to my markers? You monster. Oops, where did example 10 go? Here it is. Okay, so now, finally, the last few examples, I've given up on factoring. I just want to show you just plain old long division. All right, and so the last examples, we're going to look at a long division, and I'm going to show you what it means in terms of what are called rational functions. So what's a rational function? A rational function is just when you take two polynomials and you divide them. So like this calculation here, all right, what does it mean? It means something about, it tells us something about how to simplify a rational function. And let me actually kind of work over here for a second. All right, so Benjamin. So let me write down here what this means. So what this means is that if you take x to the 4th, all right, x to the 4th plus 2x cubed, all right, 2x cubed plus 2x squared, all right, minus 14x plus 36. All right, you take that. And you divide that bad boy there by x squared plus 3x plus 2. It turns out that this is equal to, all right, what's it equal to? Well, it is equal to x squared minus x plus 3. Excuse me, my bad. Oh yeah, x squared minus x plus 3, all right? And then here's the new thing for us. The remainder is minus 21x plus 30, so plus minus 21x plus 30. Hey, give that back. Trying to steal my marker, little monster. Divided by x squared plus 3x plus 2, okay? So that is what the long division means. So on the handout sheet I give to you guys, I'm going to say, what is this long division? What does the long division in example 10 mean? Okay, what does it mean? It means this equation right here. This is the answer to example 10. X squared plus 2x cubed plus 2x squared minus, whoa, that was not good. Tripping over my own feet. That's the meaning for example 10. If we divide that 4th order polynomial by that quadratic, we get a quadratic x squared minus x plus 3 plus this fraction, all right? So you could say this is what's called an improper, this right here would be an improper rational function, improper rational function. Over here, you got yourself a proper rational function. So just like proper and improper fractions of numbers, proper rational function. So a proper rational function is simply this. It's got the degree of the numerator is smaller than the degree of the denominator. I see I am not able to say more. Here's example 11. Maybe I won't bring him to here when we have students in person. Maybe I shouldn't. All right, so that was the example 10 answer. Here's example 11. All right, so example 11 there. I've got this fourth order polynomial, right? And I'm dividing x to the fourth minus 16 into this, and I get 1. What does that mean? What does that mean? All right, so let me write the equation that it means. That's going to be your answer on the participation sheet for number 11. All right. And I should have that participation sheet posted here in a bit. Okay, so we've got x to the fourth, if I could remember, plus 3x cubed plus 2x squared. All right, 2x squared minus 4x plus 10. I'm dividing that by x to the fourth power minus 16. How does that simplify? Long division tells me that that simplifies to 1 plus what? Plus, there's my remainder. See, this is my remainder now. That's the remainder. Once the thing you're writing down here has a smaller degree than your divisor, then you're done. So here we are dividing by x to the fourth. We got to x cubed down here. That means we're done. And so we've got plus 3x cubed plus 2x squared minus 4x plus 26, all divided by x to the power 4 minus 16. All right. And that's what this calculation right here means. It means that if we divide this quartic by that quartic, it's equal to 1 plus this, what's this called right here, this proper rational function. So there you go. That's the example 11 answer. Let me move on here to example 12, which will be our final example. Then Benjamin and I will be able to go home. All right. So, uh-oh. Well, I hope that was visible. If it wasn't visible, well, I guess I won't know. Rats. Well, I think it was visible. All right. So example 12 here. What does this long division mean? All right. Oh, Benjamin, that is my special marker. Don't mess with that, buddy. Oh, man. Oh, Benjamin. That one I can't just get. That one's hard for me to get. Okay, so we've got x to the power 4 plus 3x cubed plus 2x squared minus 4x plus 10. And this time I'm dividing, what am I dividing into it? X squared minus 9. Okay, so the answer is x squared plus 3x plus 11. All right, and then the remainder down here, notice we had to stop when we got to power x because we're dividing by a quadratic. Once you get to a linear term, that means you're done. Okay, and so the remainder here, 23x plus 109 divided by x squared minus 9. So there you go. That's what example 12 means. That is the meaning of that long division like that. Yeah. So the last few examples weren't really about factoring. They're just my including them in the course. It has an application to when we study how to simplify rational functions. All right, which we're getting to, and this will be relevant as we think about graphing rational functions. But I don't know. you know, I might ask you one of these long division kind of problems on the next test, but I think that the bulk of your responsibility on the next test is more going to be geared on like just graphing and factoring and things like that. So long division is something you want to learn, but it's not the end-all be-all going forward. We are done. Benjamin, say bye.
Bye.
You say bye?
Bye.
Okay, bye then.